Dear students, today we are discussing uh, some theorems on bounds. Another theorem is minimax theorem, minimax bounds. So for that, before that you can discuss this 3.8 section. Some examples is given there. Okay, so you can look at that example and try to find out the bounds also. Okay, and one among you can take this example as a seminar. Okay, so now we will look on the minimax bounds. So here we considering a coherent system. So what is the structure function of a coherent system? Phi of x1 x2 etc etc. Okay, so and suppose that, so let us denote the structure function of a coherent system as phi of x1 comma etc xn. Okay, so and let's p1 p2 etc pn denote the minimal paths p1 comma p2 comma p p small p be the minimal paths. Okay, and let q k1 k2 etc k be the minimal cuts k1 comma k2 comma etc k be the minimal cuts. Okay, minimal pass. So we have a coherent system and its corresponding minimal pass and minimal cuts. Okay, so the theorem says that uh, minimum of minimum of probability of, sorry, maximum of probability of minimum of xi equal to 1 is less than or equal to less than or equal to probability of phi of x equal to phi of x equal to 1 less than or equal to minimum of probability of maximum of xi equal to 1. Okay, so this is the result we have to prove. What is that? And the minimum is taken over all. uh, Let us put the range of selection. Maximum is taken over 1 less than or equal to uh, or less than or equal to p. So maximum is taken over all minimal paths. And here the minimum is taken over all the components in the corresponding minimal path. So that is I belongs to pi or pr. Okay, xi, and in the right side we can have the minimum is taken over all possible minimal cuts, so that 1 less than or equal to 1 less than or equal to then s less than or equal to k, and this maximum is taken over all components that belongs to that minimal cut. I belongs to ks. Okay, so this is the result we have to prove. For the proof, uh, And moreover, in addition, one more result, equation 3.12c is given. Instead of writing probability, we write the probability in terms of component probabilities. Okay, that we will prove as we reach the in that step. Okay, so let us first prove the main result. After that, we can prove the additional result using this main result. Okay. You know what is phi of x? Phi of x can be represented in two ways. What are the ways? Minimum, maximum, or maximum, minimum. That is, we have already discussed in detail phi of xn comma etc. xn can be written as maximum of, you can put here the maximum, maximum of then minimum of minimum is taken over I belongs to, I think we have already derived this particular format. I belongs to PR xi. Maximum is taken over 1 less than or equal to 1 less than or equal to r less than or equal to, what is that, p. The possible number of minimal paths is p. So again we can represent in terms of minimal cuts. So we can again represent phi of x as, this is minimum of 1 less than or equal to s less than or equal to k. This is alternative representation of the system structure. Okay, so these are the two representations. Okay, now to prove the minimax bound result, we will page one page is missing. That will be that page will be taken and put it in that presentation. No problem. So that minimax bounds. So we have two representation. One is minimax representation and another is max minimum representation. Okay, so the next step we have to determine is, you know that in the first representation we have maximum minimum. So this phi of x is the maximum of this one. So definitely we can write like this. So this is the maximum value. So we can put like this. This is greater than or equal to this one, because this representation maximum representation. So if we remove the maximum term, then this will be greater than or equal to minimum of xi. Similarly, if we consider this expression, so we can, this is the minimum of maximum. So this will be less than or equal to the representation maximum of xi. Okay, so we obtain two additional representation, that is this phi of x is greater than or minimum of xi, and this phi of x is also less than or equal to maximum of xi. So we can combine these two expressions so that we will get okay. So we obtain this expression. We can remove this one. So simply using these two expression, we can write minimum of xi less than or equal to phi of x next to xn less than or equal to maximum of xi. Now we can take expectation on both sides. Then what happens? Take the expectation on each side. So what will be the next step? So take the expectation on each side, right? Now we will, what is aspiration actually? These are all binary random variables, so we can write the aspiration as probability. Okay, this is probability of this one equal to 1. Okay, and this is also probability of what? This one equal to 1. This is also probability of maximum of xi equal to 1. Okay, so we obtained one equation. Let us denote it as equation number 1. Okay, now we will so we have this expression, and we can maximize this expression with respect to 1 less than with respect to maximum 1 less than or equal to r less than or equal to p. So maximize this expression equation number 1 with respect to maximize with respect to 1 less than or equal to r less than or equal to p. That is possible. Or we can maximize each side with respect to 1 less than or equal to r less than or equal to p. Okay, so this operation can be applied to all sides. It will come here, it will also come here. Okay, but you know that here there is no r, so maximizing a constant with respect to r, sorry, there is no term in r, we can consider here in the center part there is no r here to maximize. Okay, so this is actually this term itself, no problem. And here also there is no term with r right side, so we can remove this one also. So same value will be appear there. So this is equation number 2, and this is equation number 3. Okay. Now what will be the next step? We can minimize with respect to k. So what happens? This again we will have minimum, and you can put the minimization operation in each side. Okay, 1 less than or equal to s less than or equal to k, right? So we will minimize with respect to yes each side. So what is the possibility? What will be the next step? Yeah, it is equation number 4. What will be the next step? As in the previous case, you can see that there is no term in S for the first and second term. So we can remove this one. No problem. We don't want to. We don't put that minimization application here because it is a constant with respect to S. This center part is also a constant with respect to S, so we can remove this. Only the third part contains the S term, so we can keep that expression in the third term. So this is equation number 5. So what is this? This is the required result. Okay, this is the required result. Now, you know that I will take that. Yeah, in this you can see. Yeah, this is the step we have discussed now. Now, what will be the next step? Yeah, we have to prove one more result, that is, let us take this one to this one here. You can put it one more slide here and paste the web page here, or we can take from here. Okay, so we have put that result here. So now what we have to prove? The next step is if in addition the components are associated, then the more explicit bound can be held. So you know that in the case of associated random variables, you know that this probability probability of, in the case of associated random variables, you know, this probability can be written like this. This is actually product. We can put the product term there. So this is actually product. So in the associated case, you know that this is greater than or equal to, what is that, product of pxi, or greater or less, what is the result? In the case of product, yeah, it is given here 3.1. It is greater than or equal to. Okay, so this can be written as greater than or equal to probability of xi equal to 1. Okay, I belongs to PR. Okay, so this is the result. This is true for, understand, this is true for associated random variables. So we can replace with this term. So let us take this equation number 5, and it can be write it again, and we can replace with this term. Okay, instead of this one we can replace the term lesser than the actual term. Okay, this is lesser than the probability this term. Okay, similarly, in the case of uh, uh, associated random variables, you have this result. What is this actually? This is exactly probability of union. Okay, so this is probability of union. I belongs to I think it is ks. Ks instead of ps we can write like ks. I think that is the notation they have used. Yeah, that is ks. ps will be written for paths. It is cut actually. Sorry for mistake I have written here. It is actually ks. Notation yes, but at the same time we forgot to write k. That represents actually cut set. Okay, you yeah, it is there. At the same time we have used case. Okay, this is ks xi equal to 1. Okay, but this is less than or equal to, yeah, already proved that this is less than or equal to, what is that expression? Union I belongs to ks probability of xi equal to 1. Okay, so we can again rewrite this equation number 6. We can take this right side and put instead of probability of maximum equal to 1. Equation number 7. Okay, so this is what we have to prove as the corollary, so not corollary, as 3.12, equation 3.12. Okay, so this is actually equation 3.12. Instead of p of x equal to, we can write pa, so that will also we will. Want to in your uh, teaching material. Okay, so I think you can understand this theorem. This is important. Bounds, minimax bounds. Okay, so you can study. I will share this proof with you, and you study and submit. I looked into the assignment you have submitted. I could see that many of the students has not submitted assignments. That means the notes I have given during the discussion. So I cannot agree with you in that uh, matter. You have to submit these notes. I have to see whether you are writing the notes or not. If you are writing the notes, you will get the maximum mark in your assignment. If you are not writing the notes, you will not uh, you cannot claim the assignment mark. Okay, this is my assignment actually. So you have to write each and every note, and with the help of this book and the material I have supplied and the video I have given, okay, using that you have to write the note as your own. Okay, so that should be rectified during this week. If you are not done, you have to correct it and submit in this week itself. And the next week we will start with the discussion on next chapter, next module. Okay, so uh, and you will have an examination in this week, and before that examination you have to complete each and every note. Okay, so I expect your obedience on this matter, and I feel you are very intelligent, good students having good behavior. I cannot think about the this worst situation. If you are not studying, I cannot think about that situation. Okay, you have to study, write, and submit. Otherwise, I cannot support you in uh, what is that, coming activities. Okay.